Hi, welcome back. Welcome back to our discussion on coordinate geometry. This is Bundy and I would be today talking about polar coordinates. So polar coordinates are a different way to represent points in space. For example, we have already, until now we have seen at rectangular coordinates where you represented a point in space using two coordinates x and y. The distance from the x-axis and the distance from the y-axis. But now we will be looking at a totally different way of looking at points. That is, we look at a point as distance from the origin and the angle that it subtends. Alright, so this is the polar coordinates. So in polar coordinates you have r theta representing a point. That is nothing but r is the distance of the point from the origin, and theta is the angle between the x-axis and the line joining the origin and the point. Alright, so that's it. So this is the summary, the main point of the polar coordinates. Here what we are changing is, we are not changing any geometry here. What we are changing is, we are changing the way we represent points, right? So how does this relate with the rectangular coordinates that we had previously? So in case of rectangular coordinates, we had something like, x comma y, right? Where x is this distance and y is this distance. So how does it relate with the x and y's? Let's see that. So you see that given a point P, r comma theta, the distance given a point P, which is r comma theta, the distance from the x-axis is r sine theta and this is r cos theta, right? Therefore, in rectangular coordinates, the coordinates of the point P are nothing but r cos theta and r sine theta. Therefore, we see a direct relationship between a point in polar coordinates and a point in rectangular coordinates. In particular, if you are given a point in polar coordinates, you can get the coordinates in the rectangular coordinates, and if you are given this point, then you can get it back. And how do you do that? We'll see now. So given a point in, say, rectangular coordinates, that is, you know the point here as x comma y, that is nothing but this distance is y and this distance is x, right? Therefore, what is the value of this? R is nothing but, by Pythagoras theorem, r square is equal to x square plus y square, right? And what is tan theta? Tan theta is y over x. And therefore, the value of r is square root of x square plus y square, and value of theta is tan inverse y by x. Okay? So given a point in rectangular coordinates, we can get the polar coordinates back using this expression. And similarly, given a point in polar coordinates, we have already seen how to get back its rectangular coordinates like this. Therefore, it's not really a new geometry that we are learning, but it's a new way of representing the geometrical objects that we are learning. And in particular, this way of representing points is useful because ellipses, circles, and conic sections in particular can be represented using a very, very simple and beautiful formulae.